set of all possible outcomes. Okay, so sample space is S, and it is the set of possible outcomes. S, set of possible outcomes. Then the probability is the chance an event occurs out of all outcomes. So you look for one specific event to happen out of all of the possible events that can happen in that sample space. And then the event is a collection of outcomes from the sample space, which is a subset of. So we take all of the possible outcomes and we find the sample space. We are going to spend some time with probability. Probability is not super highly tested, but it is something that we need to spend a little bit of time with, just making sure you can do some basic probabilities. I think most of you will be okay with that.
Yeah.
So here is a sample space right here. What are these? Dice. And I'm rolling one die and then I'm rolling another die, and that's going to give me 2 dice in one event of rolling the dice. Below is the sample space of rolling 2 die. So when I look at this, I want to know, first of all, I can have lots of different ways I can do this. I can say that I got a 1, 1, that's a sample space outcome. I can say I got a 2 and then a 1. I can say I got a 3 and then a 1. Or I can say, what are the sums on those dice? So if I take 1 plus 1, then how much is that?
2.
So the sum is 2. What's the sum of this one?
3.
Sum of that one?
Oh, there's a little trick.
And then
Just
5,
go over.
6,
3,
7.
4, 5.
And then that'll be 3, 4, 5, 6, 7, 8. And then 4, 5,
I
6,
think the base
7,
possibility is like 7.
8, 9. And then 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, and 12. So that is the sample space of the sums. And typically on the AP test, typically what they want is that you can imagine these dice and the sums that they get. So there aren't just 12 sums that you get. You actually get 36 sums. Well, actually not 12. So we go 2 to 12. So yeah, because we don't have 1 as a sum. But we would end up with how many total possible sums that could happen. Because a 3 and a 1 and a 1 and a 3 is considered unique and they're different. So if we take 6 possibilities times 6 possibilities, that means we get a total of 36 outcomes. While this one is an 8 and this one is an 8, they are different. A 3, 5 and a 5, 3 is different in the order that we rolled them. The 5, 3 and the 3, 5 is different. So we have a total of 36 outcomes. So looking at this, what is the probability that the sum will be 5? What is the probability that the sum is 5? So first of all, look for how many outcomes add to 5. There are 4 of them. Out of the total possible outcomes, how many total are there? 36. And then always reduce the fractions if you can. So 4 over 36 will make 1 over 9. So probabilities can be written as fractions, probabilities can be written as decimals, but they are never written as percentages. If it says what is the percentage, then you make it a percent. Otherwise it is just that, like this. Okay. So I'm going to throw in a few extra examples here, just in that blank space over to the side, just to practice with. So what is the probability that you get a sum of at least 4?
What's the probability? Well, let's see.
At least 4. So it is out of 36 always.
There's
What is
33
it?
and 36, so it's 11, 12.
So I could count up everything from 4 over to 12, But what might be faster?
Just exclude that little corner.
Yeah, get rid of the ones that aren't in that, there's only 3 of them. So I know that there's a total of 36 minus the 3 that don't fit it, and that would be 33 out of 36. And always reduce if you can, so those are both divisible by 3. Is it 11 out of 12? Is that right? So I could count them all. In worst case scenario, I'd just do it. Alright, what is the probability that we get a sum of 7 or 9? A sum of 7 or 9. So we wanna look for how many ways or how many outcomes give us a 7 or a 9. And then that is still out of the total outcomes. So how many sums of 7 do we get? 6. How many 9s do we get? 4. So we add these together because we're looking for a 7 or a 9. And that'll be 10 out of 36. And we reduce that, they're both divisible by 2. So that'll be 5 over 18. Are you good with this? Is this easy? Is this easy? Okay. Do you want me to give you one that's a little more challenging? What's the probability that you get a sum divisible by 3, 4, 5? A sum divisible by 3 or 5. So what does that mean?
It has to be, it can be divided by 5 or it can be divided by 3.
Yeah. So there's a couple different cases. It can be divided by 5 or it can be divided by 3. So 3, 6, 9, and 12 are all divisible by 3. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that right? 12 divisible by 3? How many divisible by 5? 1, 2, 3, 4, 5, 6, 7. Is that right? And then 12 plus 7? 19 out of 36. Does that reduce at all?
Oh, it's just
I think so.
So 19 out of 36 ways that can happen. Notice that there is no number that's divisible by both 3 and 5, right? What would the
What?
number have to be
15?
divisible? It has to be 15. That's gonna be a
30?
special case that will happen when if we looked at 3 and 4. If it repeats or if it overlaps in any case, then we can't count it twice. So we'll get into that probability just a little bit more when we look at those. Okay, so is that okay, looking at those? Dice are typical on there. They'll always ask a question about that, just making
Okay,
sure you
so
know the
if they
subs.
had a 15 on this,
Yep.
we would only count it, like, we wouldn't count it as 13 things were divisible by 3 and 8 things were divisible by 5. We'd only count it as like 13 plus 7
Yes.
or 12 plus 8.
Correct, yeah,
Okay.
we would not have an overlap, and we'll get into those too. So the event is what you're looking for to happen, so the sum of 7 or 9 is the event, sum of at least 4 is the event, sum divisible by 3 or 4, or 3 or 5 is the event, and then the total outcomes is 36, so it's out of a total. Alright, what's next? Complement. So it says on here on the paper, we're gonna fill this paper in, it says the complement of an event is the probability of an event blank occurring. If PE symbolizes the probability of an event blank, or then blank symbolizes the complement of the event, a complement of an event can be found by blank. And so the sample, using 2 dice, find the probability that the sum is not 5, which is what we've done already. So hopefully you have your sums written down. I'm gonna slide this up. And we're gonna fill in those things. So the complement of an event is the probability of an event not occurring. complement means that it does not occur. If PE, the probability of the event, symbolizes the probability of an event, then this is the way we write that it does not occur. It's the probability of the event prime not occurring. So that does not mean take the derivative if you're in calculus. It means prime, E prime. E prime means that E does not happen, that E does not occur. It is the complement of E. Symbolizes the complement of the event. And a complement of an event can be found by taking, so I'm gonna do probability of E prime equals 1 minus the probability of the event. So if you know that it's a 20% chance of rain today, then I could find the probability of it not raining by taking 1 minus 20% or 0.2. 100 minus 20%. So how do we find the probability that the sum is not 5?
So you take 36 minus 4.
So not 5 is 1 minus the probability that it is 5, which would be 1 minus, how many did you say?
35.
How many are 5?
There's 4 that are 5.
So we would take 1 minus the probability, which in this case, it's the rest of them, right?
Yeah, so could you not just take 36 minus 4 and then put that over 36?
Yep, because it's really like 36 over 36. Remember that the AP test wants you to put trivial things down. So trivial means like show your work, even though it's a basic concept of 36 minus 4. Do that 36 minus 4, and then
You got 37.
37.
No, I'm just kidding.
What's
But
30?
could you not just write that last part, 36 over 36 minus 4 over 36 equals 32 over 36?
I think so.
Okay.
And then reduce that.
Can you reduce it first and make it 1 minus 1.9?
Yeah, you could. That'd work too. So that's 36. Those are both divisible by 4. So that's going to be 8 ninths. Is that right?
Yep.
So always simplest form. Always, you know, the AP test isn't so picky about rounding and reducing and stuff, but sometimes they are. And there's no rhyme or reason as to when or why, but making sure you simplify is always a good idea. So the probability of not a 5. Okay, what is the probability that the sum is not 0? Just as an extra example. What is the probability that the sum is not 0?
100%.
Are they all more than 0 or are they all not 0? So there are times where it is the whole sample space. What is the probability that it is a number 2 through 12?
1.
Is that also 1?
Yes.
What is the probability that the sum is 15?
0.
So there are times where, right, it's impossible. So it can be a specific one between 0 and 1, or it can be the case of impossibility, or 100%, what's the opposite of impossible? Possible, but in the case of 100%,
0%.
it's going to happen. It's going to happen.
Absolute.
It is absolute, I don't know, absolute versus impossible. We could do that. All right, mutually exclusive. Mutually exclusive, when I think about that, I think about people dating each other or being married or however you guys call it now, I don't know.
What?
When you're like, you two are the only two together and you're like boyfriend, girlfriend, what do you call that?
Wasting your time.
If you're, because it used to be that people who were talking meant you were together.
No.
But then dating meant that you were together, but then like,
No.
what is it when you're
If you were talking to
Always.
someone, you are not like exclusively, like you don't have to exclusively be talking to one person.
okay.
But
So what is it when you're
dating someone, that's exclusive.
dating is exclusive?
Yes.
Is that, okay. So mutually exclusive, mutually exclusive is like thinking about dating. So two events are mutually exclusive if they blank happen at the same time. So they are mutually exclusive if they cannot happen at the same time. So, for example, what is the probability that both of the numbers are even and you get a sum of 5? So is there any case in those dice where both of the dice are even numbers and you also get a sum of 5?
Yes.
And those two things happen at the same time.
Yes.
Both dice are even. So like a 2 or a 4.
Dice are even?
Both dice are even.
Oh, wait.
And it's a sum of 5.
Yeah. When you get 10, 6 and 4, they're both
The
even.
sum has to be 5.
Oh, it is a sum of 5.
It has to be a sum of 5.
No, it's
Right.
impossible.
So these are considered mutually exclusive, or there's another word that we like to call this, and it is disjoint, which means they cannot happen at the same time. Mutually exclusive. So what I imagine is, we're gonna talk about Venn diagrams, and I want you to draw a little Venn diagram over here. And a Venn diagram is like a sample space box with 2 circles in it. Did we do this already?
Yeah.
So here's the couple, the 2 that are dating, and then here's everybody else. Everybody else.
And then in the middle is a talking phase.
So, if you are mutually exclusive, then where are you located? You are over here. So let's say that A and B are the ones that are mutually exclusive. You call it dating. So A and B are dating. If you are definitely mutually exclusive, then that means there's nobody in the overlap. You're not talking to anybody. Everybody else is over here.
But
So
I'm
like
dating 2
C
people
through
from
Z
one.
is out here. So if you are mutually exclusive, there's nobody in the overlap of the 2 circles. So you are in your own circle. This is called disjoint. 2 totally separate groups. You and your significant other, everybody else.
So if you were looking for something that was
What if
both
I'm
are
Mormon
even.
and I have 2
Hold on.
girlfriends?
Go, so what?
What if I'm Mormon and I have 2 girlfriends?
Well, then there is no way for it to be mutually exclusive.
Okay.
So what is it called when something is both, if like if the question was both are even and it's a multiple of 5 and you have the overlap, what
Then
is that called?
then those are, they just are joint,
Okay.
right? It's either mutually exclusive or, inclusive. That's what the other term is here,
Oh, okay.
inclusive. So 2 events are inclusive if they
Is that still texting?
Can happen at the same time.
can happen at the same time. Let's put that word in. So, the probability of at least one number is 2 and the sum is even. What is the definition of an even number? It has to be divisible by 2. So I almost want to say that inclusive is, not that it can happen, but that it will always happen. If it's inclusive, then it will always happen. But P, at least one number is 2, then the sum is even. If you look at every pair of dice where one of the die is 2, they will all be even.
No.
The sums will all be
2
even.
and 1.
Oh, 2 and 1? So it's not always, right?
Yeah.
It is just can. So inclusive can happen at the same time. Does it always have to happen at the same time?
Because then you have 2 and 3 as well.
Yeah, so it doesn't always have
And
to,
2 and
but
5.
can happen inclusive. So we can have a number of 2, and it is even. 2 plus 1 is 3. That is not an
Okay,
even
so
number.
what they consider when they roll 1 dice and it's 4, and they roll another dice and it's 2, and then you roll again and the dice you rolled before was 4 is now 2, and the dice you rolled that was 2 is now 4. It's 2 separate events, even though it's the same pair of numbers.
Yes.
Okay.
Yeah, 2, 4, and 4, 2 are totally
Okay.
separate events. Separate events. So those are cases where we can have things happen. I'm thinking like, you guys are going to college. Are you allowed, do you know where you're going? Do you all know where you're going?
Yeah.
College?
Brave University.
Do you know if you're staying in a dorm or an apartment
A
or?
dorm.
Dorms? Are you allowed to have things like refrigerators and
Yes.
microwaves and stuff in your
Yeah.
dorms?
Yes.
You can? Okay.
You're not
So-
allowed, well, yeah, you're allowed to have.
Ivy Tech Community College.
So let's say
I'm gonna
that,
bring a fish.
like a mini fridge,
You're allowed to have fish
They
in
were
your dorms.
smiling.
No, I'm gonna bring one.
mini fridge,
I'm gonna go so cute. I'm gonna bring a
microwave.
snake.
Okay.
Okay, here's the.
Are any of you taking a mini fridge to your
No, I'm
college?
bringing a full size.
Yeah.
Okay, here's the thing,
Have you ever
I'm
fixed
flying
the
it
tape?
out there and then buying it while I'm there.
It goes to
Yeah.
the-
How many of you are gonna take a microwave?
It goes to
Probably not.
And I'm
honestly.
taking a.
Okay, wait. Does mini fridge count if I'm like not flying it out there with me, but I'm buying it and then bringing it with me?
Yeah.
Okay, then yes, I'm getting a mini fridge.
Are you gonna have a microwave?
No, I'm gonna bring the.
Probably not, but.
I've got one on Joseph.
So we have a couple people had their hands up for both. So 2 people are in the middle. Then we've got 3 people saying they're gonna bring a microwave only, and we have 2 people bringing a mini fridge only. That means that these mutually exclusive?
Yes.
No.
No,
Or are they
because they could overlap.
Yeah, they are inclusive because they can happen at the same
I've
time.
never done that.
But mutually exclusive.
I don't know if I'm allowed to have microwave in my dorm. Even if I did, there's like every floor in the dorm has its own lounge, and every lounge has a kitchen in it
Never have I ever had a crush.
that has a microwave. So like, even if I was gonna microwave something, I would just use the lounge because you're allowed to use it 24 hours.
No.
All right, one more thing here.
I doubt someone's gonna be happy
Probability
with
of
it.
A and B.
Lounge at 1
Oh, wait a minute, I put that in the wrong spot.
I'm out, so I guess.
a.m. I'm also gonna have a dorm room to myself, so like,
Lied to get
What?
J off.
yeah,
I might too.
I'm gonna do that too.
you, some college kids, not.
Well, honestly, no, because then you won't have like a little buddy to like figure out the college.
I will have my little team.
Alright,
I
so
also
here are the 2 cases when we talk about numbers. Please take a look at this. Told you I gotta keep going fast.
It's a really, like, there's.
Ladies, I know, I got you off track. I want it to be relatable, but we gotta stay on focus. So, the probability that A and B happen together if there's 2 different groups,
We have 13 minutes.
in the case of mutually exclusive, it's 0.
Zero.
If it's the case of inclusive, the probability of A and B cannot equal 0. It has to be something. There has to be something in the overlap. In the case of this, we had 2 people out of 7 people. That's a probability
Only
other than
7
0.
people in this class?
I just, only 7 people answered me.
Oh, there has to be
Well,
like
5 people answered me. So those are the probabilities, those are the things that we have happening.
Is it advisory?
Not yet,
Can I go to Philly?
not yet. Well, we're done.
We got 13
We got a few minutes. All right, we have to do the rules of probability. So I think we already talked about these, but I want to pull those back again. So it all happens over and over and over. Rules of probability. Probability is between 0 and 1. So we rewrite it as Stay with me, guys. I know we've got a little bit of time.
Wait, hold on, what are you recording this for?
For the independent study people.
Okay, as long as
So
it's not going
hopefully
on
you're not
YouTube.
saying inappropriate things.
Wait, is it going on YouTube?
It might.
No, don't put it on YouTube. We're playing Never Have I Ever. A bunch of stuff.
We're
going
probably
to-
hearing all of it.
we're
Alright,
all going to jail.
all probability is between 0 and 1. So we would say that 0 is less than or equal to the probability of any event is less than or equal to 1. All possible outcomes together must have probabilities whose. What do you think goes there?
Two sums equal 1.
Yep.
Which hip hop artist?
Sums equal 1. If all outcomes are equally likely, the probability of an event A occurring can be found by using this formula. It's a very easy, you don't have to know the formula, just know the process. If you want the event here, then you find the number of ways that event can happen out of the total outcomes in the total sample space. So that's
So
the way we
basically,
find probability.
just look at the numbers. If there's 30,
Yeah.
36
Whatever you want to
events,
see happen out of the total amount that
and you want to look for 5, and 5 occurs
Yep.
10 times, and it's 10 out of 36.
Yeah. So I want to know,
So this formula is dumb.
there are 3, 6, 9 of you here today. So I could say, of the 9 of you, how many of you are going to, what is the probability of this group that I would randomly pick one of you and you would be attending college out of state, out of Indiana? So how many of you are going to attend college out of Indiana? So that would be a probability of 2 out of 9 because there are 2 people who want to go out of state. That means that the complement of that would be people who are not going out of state. How many people aren't going out of state?
Who you got? I don't know.
Who else?
Well, it's really easy, it's right here, right? Well, right now, let's just say it's 7 out of 9.
Michigan?
So in state, not in state, those should add up to a total of 1, right? Sum of 1.
Just somewhere in Michigan.
No, University of Michigan.
Oh, okay.
If the events are mutually exclusive,
University of Michigan.
then the probability of
So
Yellow
what's
and
the best
blue one,
part of
right?
me?
A and B equals
My
0.
cousin swims for Michigan State.
Make sure that I'm giving you the right formulas that I want you to put here.
Rose College.
Wait, does your cousin have the record?
Huh?
Does one of your family has the record?
My dad. Fortunately. Break it. If you break
let's
it, I'll
add
give you
a couple more things in
$100.
here.
What's your dad's
The
name?
probability of A
Mark.
or B
That's right, we were talking about it one day.
equals the probability of A plus the probability of B. So these are all 4 mutually exclusive.
No, good
I can swim backwards faster.
Yeah, no, it's in Oakland.
Write these down. I'm gonna erase them.
How much is
Hey,
Kristen.
winners don't smoke weed, champions do, according to Michael Phelps.
Michael,
Yeah.
Yeah, he won more.
I just wanna like throw that out there, like Michael Phelps, like 100%.
if the events are inclusive, then the probability of A and B does not equal
He's
0.
dead.
And then this is the probability of A or B. It's the probability of A plus the probability of B minus the probability of A and B. And we're gonna talk more about what that formula looks like and how it works as a process of finding those answers. We did, a little bit.
When we went over those formula sheets.
Yeah.
And what all the formulas were on.
Marshall.
Okay, I've got just, I think I can finish the last 3 if you guys will stay with me real quick. I wanna get through 5.2a.
He was at the JV.
We're going super fast. Okay, so 5.2a, number 1, at the bottom it says flipping coins. Imagine flipping a fair coin 3 times. Give a probability model for this chance process.
50
So
on 50.
a probability model has what are the outcomes that can happen
Heads or tails?
and what are the probabilities that can happen.
Heads or tails?
So
You get heads, heads, heads. You get
I'm
heads,
flipping a fair coin 3
heads,
times.
tails.
So I could get heads, heads,
Heads,
heads,
heads. Heads, heads, tails.
heads, heads, tails.
Heads, tails, tails. Tails, tails, tails. Tails, tails, head. Tails, head, head.
There's more. What about heads?
Tails, head, tails.
Is that all of them?
I don't know, I think so.
Yeah.
So how do I figure out how many outcomes? I'm giving you the quick
1, 2,
shortcut
3,
way.
4, 5, 6,
When I
7,
flip the
8.
first coin, how many ways can the coin
2.
land?
2.
When I flip the second coin, how many ways can it land?
2.
Third coin?
2.
If I
2 times
multiply
3
those
times 2.
together,
8.
that's 8. So 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So you think about how many ways you can get the first thing, and then multiply it by how many ways you can get the second thing, and it works for anything. So if you're trying to match outfits from your closet, you could say I've got 5 pairs of pants and 3 shirts. How many ways can I put those shirts and pants together? I can take 3 times 5 and 15. So I can have 15 different outfits by looking at that. So it works every time. So to do the probabilities, I want to really look at what are the ways I can do this. Do you want to record heads or tails when we flip?
I don't know.
Heads.
Tails.
Heads or tails?
Tails.
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 Let's do heads. I think heads are more often. Okay, so I want to know
It's a
for the
50-50
number
chance.
of heads, what is the probability of that number of heads? So number of heads, that does say H. Heads, probability of that. So I could get 3 heads, true? Is that the most heads I could get?
Yes.
So I can get 3 of them. How many could I get after 3? I could get
2.
2. Can I get one?
Yeah,
Can I get none?
yes.
So those are the possible ways that I can get heads. What is the probability that those will happen out of the total sample
But
space
can't
that I
you
have?
get, okay, wait a little. Okay, so you can get 3 once,
I can get, so that is 1 out of 8.
you can get 2 twice.
2 heads, so there's 1, 2,
3.
3.
Times. And then you can get 1 twice.
You get one.
1 head,
Where?
1,
Oh, yes, you're right.
2,
3.
3,
I cannot count.
and 0.
You
And
can
one.
get it once.
And this total sample space should add up to
8.
how much?
No, 6, 7, 8.
8 out of
8.
8, which means it adds up to
You're pressing it.
1.
1.
8 out of 8, always to
No.
1, always to 1. So 1 plus 3 plus 3 plus 1 is 8. 8 divided by 8 is 1. So this is the probability model that I would use. Most of the time this would be given to you on a problem. Sometimes you have to figure them out, and just to be able to do it quickly. Okay, I think that, we'll do that for that one. Do I have enough time to do one more? No. It's fine.
You have 5 minutes.
I still have time.
No more time.
I do have time. There's 2 more that I wanna do right there. Bedtime. Just do notes with me today, and then tomorrow you don't have to listen to me, you can just work. You can practice the things that we're doing.
So to show the legitimate probability, would you just add all those decimals together and if it equals 1, you know it's legitimate?
So I do this, I would do the sum of, why did I do that? The sum of the scores is, I'd add all those together and see if that's 1. So 0.223 plus 0.183. Seems trivial to do this. But I have to, and then I check to see if that's to 1.
Does it?
So I would show that work, I'd say, when I added all those up, that sample space was 0.223.
If it equals 0.99, do we count that as 1 or no?
It would be no.
Okay.
Is this 0.99?
Yeah.
Is it really just 0.99?
No, it shouldn't be.
Maybe that's the one.
Let me try that again.
'Cause
Oh,
threes-
no, it might not be.
No, it does.
5,
Because it's 6,
Then-
10, 20.
then, oh, it is, yeah. I missed that, another 3.
Oh, well, it would help if I did plus
Just be real careful.
subtraction.
And then that's not the only thing. The other thing is to say that all
It's pronounced what?
probabilities are between
0.223,
0 and 1.
0.235.
So show the total adds to 1 and state that all probabilities are between 0 and 1. That's important. Those are the ways we check to see if it's legitimate. And then this is really pretty easy. Find the probability that the chosen student scored 3 or better. 3 or better.
Oh,
3 or better. So, how many scored 3 or better? Which ones? Which groups? Do I include 1?
okay, I keep getting
Do I include
0.99. Somebody help.
Do I include 3? 3 or better. So which ones do I include? 3, 4, and 5. So I want to add all those together. I must show that. Seems trivial, I'm just gonna type it in my calculator, but I've gotta show the work, and then I add those together.
I've gotten 0.99 every time I've added all of them.
Let me check. They could be.
Wait, what are your 5 numbers?
0.223,
Yeah.
0.83,
Point
0.183,
Yeah.
0.235,
Yeah.
point,
It is 0.99.
0.224,
Someone made a mistake.
0.125. Yeet.
I would post that.
Bob is selling.
I was like, I've added
Why would
added
you-
it together like 20
There's-
times.
There's a problem.
And it's still
There's a problem.
0.99.
So, the intent of the problem is that, where are you going? Michael, upstairs?
Yeah.
Okay. Let's imagine that it really does add up,
Huh.
because I think that whoever created this
Well,
probably
just
just made a
assume it
typo.
from-
Yeah, they made a typo. Most of the time when you see probabilities, they will go out to 4 places, because 4 places will ensure that you get to 1. And I think they probably rounded it, not thinking about that idea that it would not work. So we would add all of those together, and that would give us the probability of 3 or better. And, you know, I don't know what that is, but we can add those together. And then we can wrap up tomorrow with the last one. And then I'm gonna give you some time to work in class.
I guess if I
Okay.
always have a one.
So, for now, the only thing that I'm gonna ask that you do at home for homework, if you will, is read chapter 5. Just read chapter 5. You don't have to take any notes. You don't have to do anything else, but read chapter 5. Start with 5.1 and go back and read chapter 5. You got it on your iPad. And if you have your assignment done, I will